Hi everyone, and welcome to our video on finding trigonometric functions based on our real numbers, based on our t-values. Okay, so we just left off on a video where they gave us the terminal point. Here is another similar problem. Here we're going to evaluate the trigonometric function ratios based on a t-value that we'll find, or that we'll use to find the terminal point. All right, so we have, let's sketch our unit circle over here. Okay, so we have t equals 5 pi over 6. All right, so I'm going to do this one in blue where it is. Okay, so it's positive, so I know it goes counterclockwise around the unit circle. I see a 6 in the denominator. I know a 6 in the denominator is close to the x-axis. So it's either this one, this one, this one, or this one. So I know this is where t equals pi sixth is though. First quadrant's the easiest to work with. So I know it's not stopping there. So I would need to go counterclockwise. I'm going, and then I'm thinking, should I stop here? Well, yeah, I should. I should stop here. This is where 5 pi sixth is because I'm looking at my 5 over 6. I know if I went halfway around the unit circle, I would have been at pi. That's 1 pi. 5 over 6 is a little smaller than 1. So I know it must end before it reaches pi. So there we are. And then still using my first quadrant information, this is the terminal point. Radical 3/2 and 1/2 in the first quadrant. The terminal point that we actually have is in quadrant 2. So that means the x-coordinate should be negative. Okay, so what we have, let's put it just right here. So because I think that's the best spot, our x-coordinate should be negative. Okay, and I'm going to kind of cloud that. So finding the trig ratios given a t-value is often finding the terminal point is our main first step. Okay, and then now I'm going to set up the same kind of table that we had before. So I'm going to do cosine of t. So however, cosine of t is fine. However, they're saying t is a number in this problem. So let me erase that and change it to that actual number. Oops. So let's do cosine of 5 pi sixth. And then let's get all of them. Sine of 5 pi sixth and tangent of 5 pi sixth. And then let me hopefully give myself enough space this time. Let's put our reciprocal trig functions next to them. So secant of 5 pi sixth. Then we've got cosecant of 5 pi sixth. And then we've got cotangent of 5 pi sixth. Okay, so there's the all 6 of them, our big 3. All right, and this is where we just remember our cosine function is based on the x-coordinate. So that was up here. Cosine of t is the x-coordinate of the terminal point. Well, our x-coordinate in this problem is the negative radical 3 over 2. That's it, done. Then our sine of 5 pi over 6 would have been the y-coordinate of that terminal point. Our y-coordinate we can see is 1/2. Then our tangent of 5 pi over 6 is the y-coordinate over the x-coordinate. So it's the sine of 5 pi over 6 answer. So it's the 1/2 divided by the x-coordinate answer, the negative radical 3/2. Okay, and we saw from before that this denominator is going to be the same every time. So that 2 and that 2 are going to cancel in this case. And we're left with the single 1 in that numerator. 1. And then we have radical 3 down below. It is negative, but I'm just going to go ahead and move the negative up top. So usually, again, we don't like to see it down below, but it's a preference thing. We just move it up top or move it to the front. Okay, so we have negative 1 over radical 3. Now, again, they don't like that square root in a denominator. So what we'll do is rationalize it, which is to multiply the top and bottom of that fraction by that square root. So we will multiply square root of 3 and square root of 3 on the top and bottom. And then what that does is, in my numerator, 1 times square root of 3 is square root of 3. It is negative, so we'll keep the negative. And then square root of 3 and square root of 3 would multiply to be just 3. So we have negative radical 3 over 3. And then now I need to find the other 3 trig functions. Now remember, these are the reciprocals of the answers we just found. So it means just flip your answers. So flipping our cosine answer would be negative 2 over radical 3. Again, I'm just keeping the negative in the numerator. Just like before, I would need to rationalize that denominator by multiplying both top and bottom by square root of 3. When we do that, negative 2 and square root of 3 multiply to give us negative 2 square root of 3. Square root of 3 and square root of 3 is just 3. Okay, so there's the secant of 5 pi over 6th. Cosecant of 5 pi over 6, I can take my sine of 5 pi over 6 answer, flip it. That would be 2 over 1. We don't really need to show the over 1. We would just write 2. Okay, so cosecant of 5 pi over 6 is 2. And then cotangent of 5 pi over 6, again, it would be flipping. This that I'm starring and this that I'm starring are the same answer. But flipping, I'm going to double star it again. Flipping the double starred one would save us time. So that would be flipping and giving us radical 3 over negative 1. Again, I don't really need to show a 1 in a denominator. The negative I can move to the front. So negative radical 3 is the answer. Okay, so there's our 6 trig ratios based on a t-value. Okay, so we find those t-values just like that. Okay, and I think that's it for now. Let's put a pause on it. Thank you for watching, and if you have questions, please let me know.